Let's do an activity to understand the phenomena of viscosity. I have kept a spoon of honey here and I am keeping a spoon of water on this tray. I'll just tilt this tray. Observe the motion of the honey and water. It is very much clear that the honey is moving very slowly as compared to water. So this is an example of the phenomena of viscosity. We'll do one more activity. Now you can see which layer stops faster. The layer near the beaker surface has stopped first and the central layers are still moving. Now it has stopped. We can observe it again. See, central layers are moving very fast. Now the outer layers which are in contact with the glass surface are very slow as compared to the central layers. The central layers are still moving, but the layer in contact with the glass surface has stopped. As the particles are stable, you can see it easily. But the central layers are still slightly in motion. It is about to stop now. So why this layer stops after some time? Why the layers in contact with the glass surface stop early and the layers which are towards the center stop later? We will study all this today. Hello everyone. You have just seen an activity which shows that when we stir some liquid in a glass, the layers in contact with the surface of the glass stop first and the layers which are at the central part stop later. But why these stop? This is the first question. Second activity, you have observed that honey and water, when these are placed at the point and the tray is tilted, which one moves faster? Water. Why water moves faster and not honey? So we are going to study the reason for that. The reason is viscosity. So what is viscosity? Viscosity is the development of an opposite force between the layers of a fluid in motion, right? So what is viscosity? It is a property by virtue of which of a fluid by virtue of which there is an opposing force between the layers of a liquid which tends to stop the relative motion between its layers. It is denoted by eta. Eta, in some books it is written as neta. The pronunciation is written as neta in some books. Now if we consider this as the surface on which the liquid is flowing. So if we have different layers, the layer in contact with the surface is at rest. So V is equal to 0. The next layer is having more velocity. The next layer is having even more. So every next layer is having more velocity. And this opposing force between every two layers is in the opposite direction, and this is called as viscous force, which is denoted by Fv, and viscosity is generally denoted by coefficient of viscosity, that is eta. I'll tell you how. Coefficient of now it is observed if we consider any two layers. You have seen two observations. We are going to derive the formula now. So if we consider any two layers, consecutive two layers, and the distance of the first layer is suppose x from the surface, and suppose the separation between the layers is dx, and this distance will be x plus dx, right? Suppose this is moving with velocity v and the next layer is moving with velocity v plus dv. That means when we move from first to second layer, the change in velocity is dv and distance is dx, right? It is observed that the viscous force is directly proportional to the area of the layers in contact, right? It is directly proportional to the rate of change of velocity with distance in a direction perpendicular to the surface. So this variation of velocity with distance in a direction perpendicular to the surface is called as velocity gradient, right? So if we combine these two, we get Fv is proportional to A dV by dx, and if we remove the proportionality sign, we get Fv is equal to eta A dV by dx. But here we need to put a minus sign, which shows that this viscous force is an opposing force. So I'll just mention the meaning of the terms, where Fv is viscous force. This is also called as viscous drag because it opposes the direction of motion of the layers. It tries to oppose the motion of the fluid. A is area of layers in contact, and dV by dx is velocity gradient, right? So what will be the dimensions of eta, that is coefficient of viscosity? You can write Fv upon A dV dx. So from here this is m Lt minus 2, this is L, this is L2, and this is Lt minus 1, because because dx is distance, dv is velocity. So what will be the dimensions? M, this will be cancelled, so L minus 1, and this will be T minus 1, right? From here we can define the coefficient of viscosity. So from equation 1, if A is equal to 1 meter square, dv by dx is 1. This will be 1 meter per second upon meter. So if this is also unit, so Fv will be equal to coefficient of viscosity numerically. So I can say that coefficient of viscosity is the viscous drag between layers of unit area of contact and unit velocity gradient, right? Its SI unit is decapoise, or also called as Poiseuille. Right? So this was all about the basic concept of viscosity. Now we'll compare. This is also an opposing force between the layers of a fluid. Now we'll compare viscous force and friction force. This is friction force. So viscous force is directly proportional to the area of liquid in contact, area of the layers of the liquids in contact. It does not depend on area. Friction force does not depend on area. It depends on normal reaction. Friction force depends on normal reaction. Does not depend. These are the basic points of difference between the two. We can also write it depends on the velocity gradient. Viscous force depends on the velocity gradient. It does not depend. Here we can mention the factors affecting viscosity also. You must have seen that in winters what happens that your automobile engine is sometimes jammed. So that is due to the viscosity of the oil. So for liquids, viscosity is inversely proportional to temperature, right? For gases, viscosity is directly proportional to temperature, right? So this was the basic idea of viscosity, right? So that's all for now. Have a nice day.